Hello everyone and welcome to my talk about the collections we have in JavaScript. We have various types of collections and most likely that you are already familiar with most of them. We can categorize those collections into three groups. There is the indexed collections such as the array, there is the keyed collections such as map, and there is the group we call DOM collections. Those are the collections we work with when working with the DOM, the document object model, when adding a new element to the page or extracting values from specific elements by interacting with the DOM. We find ourselves working with unique collections for the DOM. Let's start with talking about the array. The array is probably the most well-known collection in JavaScript. An array in JavaScript is actually an object that holds its element in cells. Each cell has an index number starting from 0. The first cell, its index number is 0, the second is 1, and so on. Now, working with an array, you actually work with an object that was instantiated using the array constructor function. Now, if you check the properties that the array.prototype has, these are actually functions you can use when working with an array, and there are lots of functions. So if you are not familiar with those functions, I strongly recommend go over these functions, try to explore. The documentation on the MDN website is excellent. Now, the best practice is to create an array using square brackets. When creating an array using square bracket, indirectly a new object is instantiated using the array constructor function. So it is actually the same whether you interact directly with the array constructor function or indirectly because you chose to use square brackets. Now, using square brackets, this is the best practice. This is the recommended way, and that is because if you use the array constructor function and you pass over a number, you actually get a new array that is its size is the number you pass over. That might confuse because we also have the possibility to create a new array object passing over an element and then get an array with that element as a single element, an array that its size is 1. So that might confuse some developers who might think that if you pass a number, you get an array that its size is 1 and its element is just a single number. Because of that, the best practice would be using square brackets. A part of the simple well-known array, we also have in JavaScript typed arrays. Those typed arrays are kind of array. However, if you check the MDN documentation, you will see that there are lots of possibilities, and those options are relevant when dealing with huge amount of binary data. For example, if you are working with a huge amount of numbers, most likely the performance will be much better if you use the relevant typed array instead of using a simple array. So I strongly recommend pay attention to this option. It might improve the performance significantly of your code. Now, working with an object is also a way for storing data. An object in JavaScript is, after all, just a simple collection of key-value pairs. The keys must be either a simple plain string or a symbol. The values can be of any type you want. Now, when you create an object, you actually get a collection of key-value pairs. Getting the value of a specific key can be done either using the dot notation. For instance, in this code sample, student is a variable that holds the reference for an object with the keys ID, name, and average. So I can write student.name and get the value of the property name, the value that is attached to the key name. There is another way for getting the value of a specific key. We can treat the object as if it was an array and specify the key as a string within square brackets. Here in this code sample, the second line will print the value of the key ID. Comparing arrays and objects when dealing with accessing a specific element, getting the value of a specific element, the time complexity is actually the same, or 1. When dealing with inserting or deleting elements from the end of the array by calling the functions push and pop, for instance, the time complexity will remain O1, just as as it is when working with an object trying to add or delete a specific key value pair. However, when working with an array and the element is not at the end and we want to delete it, or maybe we want to insert a new element in between, then the time complexity grows and it might be even O(n). So take that into consideration. If you hold the data using an array and you have the need to remove specific element in the middle or adding new elements into the middle, the complexity won't remain O1, it might become even O(n). So take that into consideration. Now let's talk about using maps. A map is a key value pair, very similar to object. However, the keys, you are not limited to strings and symbols. Now, creating a map is fairly simple. Just new map and you have a map object. And then you can call various methods in order to add key value pairs. Let's take a look at the MDN documentation. So creating a map is very simple, and then there are lots of methods you can invoke on the new created map in order to add new key value pairs or get the value of a specific key and so on. Now the keys are unique. If you will try to add a key value pair and that key already exists, that key value pair won't be added. What will happen is actually an update to the key value pair that already exists. The value will be updated. Now, when using a map, unlikely when using an object, we don't have default keys coming from the prototype. I mean, if you are using a map and you add key value pair, there is no risk that for some reason you will find yourself specifying a key that actually already exists because it comes from the prototype. When using an object, then that accident might happen. You might find yourself adding a key value pair and that specific key actually already exists because it comes from the prototype. And that might lead to some sort of a disaster in your application. So you must take that into account and think about that, especially when working with complex application, complex code that you are not familiar with each and every part of it. So pay attention to the potential of accidental keys when using an object for holding key value pairs. Maybe this is the main reason, in my opinion, to prefer a map over an object. When using a map, adding a new key value pair cannot collide with keys coming from the prototype. When using an object, that collision might happen, and that is a risk. That is a potential risk because hackers can use that for attacking our system. Hackers might indirectly add a specific key value pair to a specific object by knowing that the key they are using is actually a specific key that comes from the prototype, and by doing so actually override the object prototype. And that is an attack we should take into consideration. Another reason why it might be better to use map over object when dealing with key value pairs. Now, as we already said, the keys in our map can be of any type, unlike keys in object that must be either symbol or string. This is a flexibility that we might appreciate. In addition, compared with object, usually the performance when using a map would be better. After all, map was created especially for us to use a map object for holding key value pairs. Now, working with an object, on the other hand, might simplify our lives, because when we need to take and the graph of objects we have and translate it into JSON, we can do that using one method. It is very simple. The serialization of data stored in our program using objects is fairly simple. However, when using maps, that serialization is not simple. We don't have a function that will do the trick. Maybe in the future we'll have, but for now we don't. Now let's talk about set. Creating a set is suitable in those cases when we need to have unique values. We don't want to accidentally have the same value more than once. Now the values, the elements, the set old can be of any type. They can be primitive values or references for objects. And using a set is fairly simple. Just take a look at the documentation in the MDN website. So we have the constructor we can use, and then there are functions that we find as methods attached to the prototype of the set constructor functions. Those properties that you find as properties of the prototype object are actually methods you can use, you can invoke on every object you instantiate using the set constructor function. So when there is a need to work with a set of values, use set. Using set will ensure that those values, those elements you are using won't repeat themselves. Each one of them will be unique. And if by accident you will try to add to a set that already exists, an element that already exists, that element won't be added. So in this code sample, we create a set. Currency is all the set initialized with 4 values. Numbers is assigned with reference to a set object that later we add 3 numbers to it. Now, using set can be very practical for removing duplicates we have in our array. Take a look at this code sample. We have an array. The number 4 is shown twice. We want to remove all duplicates, so it is fairly simple. We just need to create a set object, initialize with those values the array holds, and then unpack those values to a new array we create and get an array with the same number the original array holds without the duplications. Now let's talk about weak set. Well, working with a weak set object is very similar to working with a set, but there is one big difference. Working with a weak set, we actually work with a collection of elements that are what we call garbage collectible, meaning it is working with objects that the garbage collector can clean, can delete from the memory. Now, the garbage collector we have in the virtual machine, its purpose is to clean the memory of objects that are no longer needed. So if, for instance, we have a program and there is an object, as long as the reference for that object is stored in a variable, it means that that object is needed. The garbage collector won't delete it from the memory. Now, imagine a scenario in which we need to work with a huge number of objects that consume huge amount of memory. And we don't want our program to crash just because we don't have enough memory. So instead of having those objects together in a set, let's put them in a weak set. By doing so, and of course, assuming that the references to those objects are not kept in any other variable, by doing so, we ensure that the program won't crash if there is a problem with the available memory. Instead, the garbage collector will start deleting those objects the weak set holds. So that might be very useful when working with objects that consume huge amount of memory, and we're afraid that because of that there will be a problem with the stack memory during the execution of our code. So we can overcome the problem, we can solve the problem simply by using a weak set instead of using a set. So by doing so, we overcome a severe problem, a severe memory problem. So you better be familiar with weak set. And the same with a weak map, the same principle. Here is a simple code sample creating a weak set and then adding objects to that weak set. As you can see, it is fairly simple. Now, when working with weak map, we actually have key value pairs. The keys must be objects that the garbage collector can collect. And what we get is a map of key value pairs. And if there is a memory problem and a key that the weak map holds, and probably it's a heavy key, a key that consumes huge amount of memory, otherwise there is no reason for using weak map. If there is a memory problem, the garbage collector will delete that key just in order to make some memory available, and by doing so the program won't crash. However, pay attention, if the reference for an object we use as a key is also stored in a simple variable somewhere, then that object won't be considered a candidate for deletion. So if you want indeed to enjoy the benefit of a weak map or weak set, make sure that those objects that are candidates to be garbage collected, their references are not stored in another place in a simple variable, because if that happens, then those objects won't be a candidate for deletion. Here's a simple code sample. I create a weak map, I add key value pairs, and the keys are the candidate for deletion. Now each key has its value, so if the key is deleted, then the value, which is another object, its reference no longer stored anywhere, so the value will be probably deleted as well, just in order to clean some of the memory, in order to allow the program to continue its execution. This is the main concern that led us to use weak map and weak set. Using a weak map might be very useful when creating a caching for a function. Just imagine that you have a function, and whenever that function is invoked, you keep using weak map the arguments that were passed to that function and as the key, and the returned value as the value. Now, doing so, you might find yourself end up with huge amount of data. On the one hand, that will speed up the use of those functions for which you develop caching. On the other hand, you risk the entire program to fail because of memory problems. So using a weak map for storing those key value pairs, the keys are the arguments, the values are the returned values. By doing this trick, you ensure that if for some reason there is a memory problem, the program won't fail, because the garbage collector will simply delete those key value pairs that weak map holds, just in order to allow the program to continue. JavaScript already supports various collections. We can use those collections, those types of collections. However, there is the option to use an external library, and by doing so, we can enjoy many more types of collections, many more possibilities. And one option I want to recommend to check out is the scl.js library. It is actually a library for those that already use TypeScript, and if you check that library, you can see that it supports many types of collections that JavaScript doesn't support, And you can also find that because that library was developed for TypeScript developers, it also supports generics, for instance, which makes this library highly useful, in my opinion. So worth knowing that we can take that library and enjoy many types of collections that JavaScript currently doesn't support. Now let's summarize what we had. We saw that there are various types of collections we can use, and my recommendation is to use that collection that fits the requirements of your program. For each scenario, there might be another type of collection that will do the job better than the others. For instance, if you need to store key value pairs, use a map. Most likely the performance will be better than using an object. If you are dealing with managing holding unique values, use set. If you are dealing with memory problems, you might want to use weak set or weak map, and so on.
Hi everyone, I'm Sam, and this is my talk about my library I wrote, the standard collections library for JavaScript and TypeScript. Just a bit about myself. I'm Sam. I started coding in my teens. I did some computer science. Then I founded a company, Accelera. It was great fun, but I quit. And now I'm just a full-time open source developer. So that's the current state of affairs. Notable projects that I'm working on is a new programming language for websites, backend and frontend, the Bolt programming language, and the Mage parser generator. That's actually a program that helps me write the Bolt programming language. That's a tool that I use internally. Now, anyways, back to SEO. What is a collection? Well, I define a collection as an interface in TypeScript with at a fundamental level, you have to be able to add elements and also know how many elements there are. Then you also need to know if it has a certain element, and you need to list the elements just in a plain iterator function. So you can use for const element of collection in JavaScript. And you also need to be able to delete elements. So that's a collection. So basically, if you look carefully, you can see it's just a CRUD. It's a mini database. Create, read, update, delete. And it's not much more than that, actually. It's not a full definition. You can see the full definition on the GitHub. I will link the slides in the chat later on. And then there are some more interfaces. For instance, sequence is for anything where the user specifies the order of the elements. For instance, a list is such a sequence. A vector is also a sequence. Then a bag, it's like a sequence, but it's never guaranteed in what order the elements are stored. So it's the reverse, okay? That's usually like a backpack. If you take out an item, you never know what you get. That's a bag, and very sometimes it's useful. Then an index, that's actually a collection also, but one that makes it easy to look up a certain subcomponent of the element. So T is the element of the collection, and K is some subcomponent of the collection that you can easily look up with. And sorted index is much the same as index. It's the only difference is that we can query things like the smallest element or the largest element or things like that. And then you have dig. Dig, that's actually like map that Michael spoke of. It's very similar to the JavaScript map. So for sequences, we have a double linked list and a single linked list. Those are at the moment all the sequences that are supported. And vector, now I think of it, sorry, my bad, another one. A single linked list is very memory efficient. It's just an arrow to the next element. in the list. But it has some bad performance characteristics. It depends on what you want to do. For instance, if you want the last element of a single linked list, it is O, and you have to traverse all elements. If you want to insert an element at a random point, it's O, and so you have to traverse all elements. On the other hand, the size is always O1, prepend is always O1, and getting the first element is always O1. Double linked list is much the same as a single linked list, but you get a pointer back to the previous element. And this allows you to do some clever tricks where actually almost all the basic operations are O1, but it takes a little bit more memory and bookkeeping because you have to store these references back to the previous node. Also, you can't efficiently query the data. You can't find... If you want to find an element in the list, you still have to traverse it. And then you have the random access data structures, hash index and vector. I won't talk a bit too much about them because hash index is basically an object or a map. So it's almost the same thing, a bit of a prettier interface. It's a bit more elegant to use than JavaScript maps. But that's all there is to it. And then you have the tree-based data structures. Those are ordered. I will show you in just a moment. You have the AVL tree index and the red-black tree index. So those are two methods to make a nice tree, a tree that you can easily query. To be honest, it was a pain to write this one. It was really difficult, but it works. Or at least I hope it works. So you see here an example of a tree. Unfortunately, I just noticed that I did wrong numbers. I put wrong numbers. Actually, at the top should be 3, and 3 should be 2, and 1 should be at the bottom. Sorry before that. I was a bit too quick. But it's actually, the concept is that left to 1, there should be an element that is smaller. So let's take 0. And right to 1, there should be an element that is larger. Let's say 5. And that's how it works. And if you want to efficiently search for an element, you can just look up if it is greater or smaller. For instance, if you want to search 5, you know 5 is greater than 1. So you go to the right and you see 5. And it can be really large. The tree can be really, really, really large. This is an example of a correct tree. This is a good one. But you see that it is really unbalanced, they say in the jargon. What do I mean with that? It's only one node here, and it's like 3 nodes here at this part. And that's not good because it slows down your lookups. If you want to search for 1, you have to traverse 3, 2, and then 1. That's too slow. So that's why you do all kinds of clever tricks. This is one from the AVL tree index. You rotate the tree. It's not important to know, but just know that it happens. And you get to the final result of a balanced node. If you see, this one is unbalanced because it's like a long chain, and this one is perfectly balanced. So that's what we want to have on the right. Now, what's the difference between the two? There are 2 different techniques to make the trees balanced. An AVL tree index is actually slightly better optimized for lookups. So it's not much of a difference, but it's there. And a red-black tree index is a good all-rounder. Actually, most programming languages use a red-black tree index. Then you have the dictionaries. There's nothing much special about them. They're actually just an index with a pair key value and indexed on, oh, this should be K. Sorry, a lot of mistakes. So it's actually a collection of pairs. A dictionary is actually a collection of pairs. That's what you need to take away from this. And there are all kinds of dictionaries. Hashdict is very fast on random lookups. A tree dict is ordered, so you can query the largest and the smallest key, which might be useful. So you need to pick the ones. It's all documented in the documentation, or it should be documented in the documentation. If it isn't, it's a bug. Now for some bonus content, I don't know if I still have time. Yeah, a bit. Well, I'm actually going to show you what I'm currently working on. So in C++, we can do the following, and I really was inspired by it. You can say an employee has an ID, a name, and an age. And then you can write an index, a collection that takes these employees and indexes them by a list, just from a order of insertion. So by the order of insertion, and then a hash on the name. So we hash the name so we can easily get the name out of the, we can easily look up whether there's an employee with a certain name. And we do an ordered index, like a tree, on the age. So we can easily query who is older than Bob, something like that. And I really like that idea. So I'm actually trying to make it in STL.js. So this is TypeScript, and we have the same ID, name, and age. And then we theoretically, this is all experimental, could write something like this. It's one of my libraries, Reflect Types, that actually lets you use TypeScript types at runtime. So we could use something like, I want this to be an object of an ID, a name, and an age, and I just say which type is an ID, which type is a name, which type is an age. And then I use this employee type here to create a collection. And then I say the same things that I said here. So that I said in this one. I say it has to be a sequence, so like a list. I want to know which element came first. I give it a name. And then I want a random access index. I call it by name. And I want it on the key of name, so this one. And then I want it ordered on by age, and I want this key on by age to be age. And optimized lookup will take an AVL tree like we've seen previously. And then we build it, and then we should be able to do something like this, and it should all work. And by the way, all of this should be typed. So that's why it's a bit strange with this by name that repeats itself twice, but that's to make it typed. So TypeScript will complain if something was wrong. And actually, that's it. It's quicker than I thought. Contributions are always welcome. Also, very important to note, this is a library that hasn't been battle tested yet. I really need people using this and seeing if there are bugs. Also expect bugs, because I do a lot of tests, but I can't cover everything. So, but it would be really great if the bugs could be squashed and new issues could be created on GitHub. So that this library really can advance to the next level. And that's it.